Hello students and good morning. So now I am doing class for class 10. The topic is trigonometrical ratios. So in the last online class we did some basic concepts on trigonometrical ratios. So I hope you have learned or memorized all the formula that we did in this chapter, trigonometrical ratios. Now we will use that formula in this chapter. That is, let us work out 23.1, page number 295 from the book Ganit Prakash for class 10 by West Bengal Board of Secondary Education. So let's do this question number 4. So question number 4 here is, if cos theta is equal to 7 upon 25, then let us determine the values of all trigonometrical ratios of the angle theta. What do you mean by all trigonometrical ratios of the angle theta? All trigonometrical ratios means you know that there are 6 trigonometrical ratios. One is sine, cos, tan, cot, sec, cosec. So you have to find out the values of sine theta, cos theta, tan theta, sec theta, cot theta as well as cosec theta. So from this given value of cos theta is equal to 7 upon 25, you should find out the values of all trigonometrical ratios, that is sine theta, tan theta, cosec theta, sec theta and cot theta. So let us find it. Okay. So here what is given? Here given is cos theta is equal to 7 upon 25. Right? So given is cos theta is equal to 7 upon 25. So in the last online class, we did the formula of cos theta in terms of perpendicular, base and hypotenuse. So what is the formula for cos theta? It is base upon hypotenuse, isn't it? You know that statement. So how can you know the formula for cos theta is equal to b by h? Some people have curly brown hair turned permanently black. Curly brown here. This means here C cos theta starts from C. So this is curly brown hair. That is, but cos theta is equal to curly. Curly means C. Brown hair. B divided by hair. Hair is H. So you know that the formula for cos theta is equal to base upon hypotenuse. Okay. So if left hand sides are equal, right hand sides must be equal. That is, you can write b by h is equal to 7 upon 25. So now in this case, you can equate the numerators as well as you can equate the denominators, right? So that is b is equal to 7 and here h is equal to 25. Since this is the ratio, all these, that is, you have to find out sine theta, tan theta, cot theta, cosec theta and sec theta, all these are ratios. That's why you can equate b with 7 and h with 25. That means you can equate the numerators, you can equate the denominators. That means here b is equal to 7 and h is equal to 25. Okay. Now in this case, what is unknown quantity? P is unknown quantity, that is perpendicular. So how can you get the value of that p that is perpendicular? You know Pythagoras theorem. What is Pythagoras theorem? H square is equal to b square plus p square. So we have proved this Pythagoras theorem statement in geometry, in theorem. That is, state and prove Pythagoras theorem. Okay. So now we know this Pythagoras theorem, h square is equal to b square plus p square. Using this relation between h, b and p, we can easily get the value for perpendicular p. So what is h out here? It is 25 whole square is equal to, what is base whole square? 7 whole square plus p square. Right? So what is 25 whole square? This is 625 is equal to, what is 7 whole square? 49 plus p square, or that is 625 minus 49 is equal to p square, or now we can subtract it. 15 minus 9 is 6, 11 minus 4 is 7 and this is your 576 is equal to p square. right? That means what is the value for p square? So p square is equal to, it is 576. So what is p now? So p is equal to square root of 576. Okay, so now let us find out the square root of 576. So how can you get the square root of 576? So I think you have done this, how to find out the square root, in class 6 or 7. You might have done it. Okay, so let us find out the square root of 576. So now how can you find it? From the last digit, you have to take the terms in pair. That is, pair of 6 is 7 and 5 is alone out here. So 2 2s are 4. If there is 2, you should write 2 here. 2 2s are 4. So 5 minus 4 is 1. Then you have to take 76. Here you can add these 2. So 2 plus 2 is 4. Okay. So now here you should write down the same number. You should write down the same number so that after multiplication you should get 176. So it will be 4. This will be 4. So 4 4s are 16, 6, 1. 4 4s are 16 plus 1 is 17. So what is square root of 576? It is 24. So here you can write p is equal to 24. So since we know p is equal to 24, b is equal to 7 and h is equal to 25, you can find out all the trigonometrical ratios now. You can find out sine theta, tan theta, cot theta, cosec theta as well as sec theta. Now first of all, let us find out sine theta. What is the formula? Some people have. Sine theta is equal to, some people have. People means p divided by h. That is, sine theta is equal to perpendicular by hypotenuse, which is equal to, what is p? P is 24 divided by, what is the value for h? It is 25. So this is 24 by 25. So this is the answer. That is the value for sine theta. Is that clear? Next, let us find out the value for tan theta. From cos theta is given, let us get tan theta. So therefore tan theta is equal to, what is the formula? What is the formula for tan theta? Turned permanently black. If tan theta is given, that is t, you have to take turned permanently black. Turn means tan theta t, permanently p, turned permanently p, black b. Tan theta is equal to p by b. What is p here? It is 24 divided by, what is base b? B is 7. So it is 24 by 7. That is your tan theta. Is that clear? So next, let us find out cosec theta. You know that cosec theta is opposite of sine theta. Cos theta is just the inverse of sine theta. Cos theta is just the inverse of sine theta, right? So if sine theta is equal to p by h, so cosec theta is equal to h by p. Cosec theta is equal to h upon p. So what is h here? 25. And what is p out here? What is the value for p? It is 24. So this is the value for cosec theta. So I hope you have understood it. That is your cosec theta. Now let us find out cot theta. So what is cot theta? Cot theta is the opposite of tan theta or inverse of tan theta. Okay. So if tan theta is equal to p by b, so what is cot theta? It is b by p, which is equal to, what is b? What is b out here? B is 7. B is 7 divided by, what is p? P is 24. So p here is 24. So that is the answer. Okay. Now cos theta is given. You can get the value for sec theta from given value for cos theta. And what is cos theta? What is the formula for cos theta? It is curly brown here. So actually cos theta is equal to curly brown here. What is curly brown here? It is b upon h. So cos theta is equal to curly brown here. That is cos theta is equal to b upon h. So sec theta is opposite of cos theta. That is sec theta is inverse of cos theta, isn't it? So sec theta is equal to, it is h by b. So what is h out here? What is h out here? It is 25. This is 25 divided by, what is base? B. Here b is 7. Here b is 7. So this is the answer. So now from the given values of cos theta is equal to 7 upon 25, we got all the trigonometrical ratios of the angle theta. That is sin theta is equal to 24 by 25, tan theta is equal to 24 by 7, cos theta is equal to 25 by 24, cot theta is equal to 7 by 24, and sec theta is equal to 25 upon 7. So these are the answers. So I think you have understood it. So you can copy it. Now we'll do the next question. So now, in the last online class, I forgot to tell you about some formulae in trigonometry. That is, I told you that sin theta and cosec theta are opposite function. That is, cosec theta is the inverse of sin theta and sin theta is the inverse of cosec theta. Okay? And cos theta and sec theta are opposite function. That is, sec theta is the inverse of cos theta and cos theta is the inverse of sec theta. Similarly, tan theta and cot theta are opposite function. That is, tan theta is the inverse of cot theta and cot theta is the inverse of tan theta. Right? So in this case, we can write down the formula. That is, therefore, that is number one. Let us write number one formula here. So number one formula is sine of an angle, that is sin theta, is equal to 1 upon cosec theta. Right? Number two, cos theta is equal to, this is 1 upon sec theta, right? Number three, tan theta is equal to 1 upon cot theta, right? So next, number four. Number four is similarly cosec theta is equal to, this is your 1 upon sin theta, right? Number five, what is number five? Sec theta is equal to 1 by cos theta. Sec theta is equal to 1 by cos theta. And number six is cot theta is equal to, this is 1 upon tan theta. Is that clear? And you should know this formula also. We have done it in the last one in class. That is number 7. That is tan theta is equal to, this is sin theta by cos theta, and number 8, cot theta is equal to, this is cos theta divided by sin theta. So these are the formula that you should know, right? These are also the formulae. These are also the formulae. Formula is singular and formulae is plural, not formulas. Formulas is not the plural of formula, right? So the plural for formula is formulae. Formula is singular and formulae is plural. Is that clear? So you can copy this formula. Now we'll do questions from the book. So now we'll do the next question, that is question number 5. So question number 5 is, if cot theta is equal to 2, the value for cot theta is given, that is cot theta is equal to 2, then let us determine the values of tan theta and sec theta. Let us determine the values of tan theta as well as sec theta. And you have to show that 1 plus tan square theta is equal to sec square theta. And you have to prove that 1 plus tan square theta is equal to sec square theta. Is that clear? Now your cot theta is equal to 2 is given. From this value for cot theta, you have to determine the values of tan theta and sec theta first. Then we can prove that 1 plus tan square theta is equal to sec square theta. Is that clear? So let us find it now. Here given is cot theta is equal to 2. Here given is cot theta is equal to 2. Now what is the formula for cot theta in terms of perpendicular base and hypotenuse? Okay, so you know tan turned permanently black. You know tan turned permanently black. That is tan theta is equal to, this is P upon B. Okay, so cot theta is just the inverse of tan theta. So what is the formula for cot theta? It is just the opposite of tan theta, isn't it? So but cot theta is equal to, it is just the opposite of tan theta, that is B upon P. Okay, so if left hand sides are equal, right hand sides must be equal. That is B by P is equal to 2 upon 1. Is that clear? So we can equate the numerator as well as denominators. That is B is equal to 2 and P is equal to 1. So what is unknown quantity here? We have to get the value for the hypotenuse. That is the value for h. So we know that from Pythagoras theorem, you know Pythagoras theorem, isn't it? From Pythagoras theorem, you can get the value for the hypotenuse, that is h. So therefore, h square is equal to b square plus p square, or h square is equal to, what is b whole square? This is your 2 whole square. Excuse me. That is b whole square is 2 whole square plus, what is p whole square? That is your 1 whole square, right? So or h square is equal to, this is 4 plus 1, or h square is equal to 5. So what is the value for h now? So here h is equal to root over 5. So here h is equal to root over 5. Is that clear? So if h square is equal to 5, so what is the value for h? That is root over 5. Okay. So now let us get the value for tan theta first. Therefore, what is tan theta is equal to? This is P by B, which is equal to, you know, turned permanently black. Tan theta is equal to P by B. So what is P here? P is 1. P is 1 divided by, what is B? What is B? P is 1, base is 2, that is B is equal to 2. Now let us find out sec theta first. So what is sec theta? So it is just the opposite of cos theta. That is curly brown hair. That is cos theta is equal to B upon H. But sec theta is just the opposite of cos theta. That is sec theta will be, that is, you know that cos theta is equal to base upon hypotenuse. Okay. So sec theta is just the opposite of cos theta. That is, it is just the inverse of cos theta. So cos sec theta is equal to h upon b. So what is h out here? Here h is root 5. H is root 5 divided by, what is b? Here b is 2. That is tan theta is equal to half and sec theta is equal to root 5 divided by 2. Okay. So we have got both the answers. That is tan theta is equal to 1 by 2 and sec theta is equal to root 5 by 2. So that is the answer. So I think you have understood it. Now let us prove this relation. That is, you have to prove that 1 plus tan square theta is equal to sec square theta. So let us prove LHS is equal to RHS. So here LHS is equal to 1 plus tan square theta is equal to 1 plus, what is tan theta out here? It is tan theta is half whole square, right? So which is equal to 1 plus half whole square is 1/4. So here how can we simplify it? 4 ones are 4 plus 1 is, this is 5 upon 4. That is your left hand side. So let us find out right hand side. That is sec square theta. That is, therefore RHS is equal to, what is RHS here? It is sec square theta. RHS here is sec square theta, which is equal to, what is the value for sec theta in this case? Just now we got it. Sec theta is equal to root 5 upon 2. So it is whole square. So it is root 5 by 2 whole square, right? So next, what will you do? What is root 5 whole square? You know that this is 5. Root 5 into root 5 is root over 25, which is equal to root over 25 is 5. Divided by what is 2 square? That is your 4. That is LHS is equal to 5 by 4. RHS is also 5 by 4. That means we have proved 1 plus tan square theta is equal to sec square theta. That is, therefore, this is LHS is equal to RHS. So it is proved. So I think you have understood it. Okay. So you can copy it. Now we'll do the next question. Now we'll do the next question, that is question number 6. So the question is, if cos theta is equal to 0.6, here the value for cos theta is given in terms of decimal, that is 0.6. Then let us show that 5 sin theta minus 3 tan theta is equal to 0. You have to prove that left hand side is equal to right hand side, that is LHS is equal to 0. Okay, so let us write down given. So here given is cos theta is equal to 0.6. Okay, and from this given value of cos theta, you can easily get the value for sin theta, tan theta using perpendicular base hypotenuse formula, right? So let us write it in terms of fraction. Therefore, cos theta is equal to, how can you write it in terms of fraction? After decimal point, how many figures are there? Only one figure is there. So you write only 6 first. Don't write decimal point. Divided by. After decimal point, there is one figure. Write 0 and then 1. That is 6 by 10. 0.6 means 6 upon 10. Okay. You can cancel it. 2 3s are 6. 2 5s are 10. So, or this is cos theta is equal to, this is your 3 upon 5. So I think you have understood it. Okay. So you know that, but cos theta is equal to, what is the formula for cos theta in terms of perpendicular base and hypotenuse? C. Cos theta is C. Curly brown here. That means you can write cos theta is equal to curly brown here B upon H. Brown here B by H. So cos theta is equal to B upon H. So if left hand sides are equal, right hand sides must be equal. That means B upon H is equal to 3 upon 5. Okay. So now we can equate the numerators. B is equal to 3. And then you can equate the denominators. That is H is equal to 5. Which is unknown out here. We know base, hypotenuse, B and H. So unknown quantity here is perpendicular. That is P. So we can use Pythagoras theorem. What is Pythagoras theorem? That is H square is equal to B square plus P square. So what is H whole square? That is your 5 whole square is equal to, what is base whole square? 3 whole square plus P square. Okay. So what is 5 whole square? That is your 25 is equal to, what is 3 whole square? 9 plus P square. Right. So, or this is 25 minus 9 is equal to P square, or 25 minus 9, you know that this is 16 is equal to P square, or P square is equal to what? It is 16. Or what is P? P is equal to square root of 16. That is P is equal to 4. So we have got the value for P. So now in order to prove this, left hand side is equal to 0. So let us find out the individual values of sin theta and tan theta. Right. So what is the formula for sin theta now? So you know that sin theta is equal to, some people have P upon H is equal to, what is P? P is 4 divided by what is H? H is equal to 5. That is, this is 4 upon 5. Next, you have to get the value for what? On the left hand side, there is tan theta. Tan theta is equal to, what is the formula for tan theta? Tan theta T turned permanently black. Permanently P divided by black B. That is, tan theta is equal to P upon B. What is P out here? It is 4 divided by what is B? B is equal to, this is 3. So we have got both the values of sin theta as well as tan theta. So sin theta is equal to 4 upon 5 and tan theta is equal to 4 upon 3. So let us put these values on the left hand side to prove LHS is equal to RHS. So now let us write down left hand side here now. So LHS is equal to, this is 5 sin theta minus 3 tan theta, which is equal to 5 into, what is sin theta? It is 4 upon 5. It is 4 upon 5 minus 3 into, what is tan theta? Tan theta is 4 upon 3. Tan theta is what? It is 4 upon 3. So you can cancel here, 5 gets cancels, here 3 gets cancels, which is equal to, this is 4 minus 4, which is equal to 0, which is equal to right hand side. So it is proved. So I hope you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 7. The question is, number 7 is cot A is equal to 4 upon 7.5. Then let us determine the values of cos A and cosec A. You have to find out the values for cos A and cosec A. And let us show that 1 plus cot square A is equal to cosec square A. Okay. Here the value for cot A is given, which is equal to 4 upon 7.5. And from here you have to get the values of cos A as well as cosec A, and you have to prove this relation, 1 plus cot square A is equal to cosec square A. So let us do it. Okay. So what is given here? So here given is cot A is equal to 4 upon 7.5. Let us convert this decimal into fraction. Or now this is cot A is equal to 4 upon, so how can you write down 7.5 in terms of fraction? So after decimal point there is one figure. So let us write 75 without decimal point. Okay. So after decimal point there is one figure. You have to write 10 and you should write 1 always. Okay. This is 75 by 10. Okay. So let us simplify it. So cot A is equal to 4 into, so when this denominator goes up in the numerator, it becomes upside down. That is, you should write 10 upon 75. Is that clear? So you can cancel here. So this is 5 2s are 10, 5 1s are 5, 5 5s are 25. 5 1s are 5, 7 minus 5 is 2, 25, 5 5s are 25. So, or now this is cot A is equal to 4 2s are 8 divided by 15. You know that, isn't it? 4 2s are 8 divided by 15. Okay. Now you should know the formula of cot A in terms of perpendicular base and hypotenuse. Okay. And you know that tan A is just the inverse of cot A, or cot A is the inverse of tan A. Right. So what is the formula for tan A in terms of perpendicular base hypotenuse? Tan T, turn permanently black. That means tan A is equal to P by B. You know that tan A is equal to P by B, but this cot A is just the inverse of tan A. If tan A is equal to P by B, then what is cot A? Cot A is B by P. So, but cot A is equal to base upon perpendicular, that is B by P. Now, if left hand sides are equal, right hand sides must be equal. That means B by P is equal to, this is 8 by 15. This is your 8 upon 15. So now you can equate the numerator and the denominator. That is, B is equal to 8 and P is equal to 15. And what is unknown quantity here? You have to get the value for H. How can you get the value for H? You can use Pythagoras theorem. You know that, isn't it? What is Pythagoras theorem? H square is equal to B square plus P square. Or H square is equal to, what is B whole square? It is 8 whole square plus what is P whole square? It is 15 whole square, right? So, or H square is equal to 8 square is 64 plus 15 whole square is 225. Or H square is equal to, this is 289. Right? So what is the value for H? That is, H is equal to square root of 289. Or what is the value for H now? Now you know that 17 into 17 is 289, isn't it? So what is the square root of 289? It is 17. Or you may divide. You can do the division method in order to get the square root of 289. So let us do division method in order to get the square root of 289. Okay, what is the pair of 9? This is 8. 2 is alone out here, so it is 1 1 1. 2 minus 1 is 1, right? So now you can write here 89. 1 plus 1, this is 1 is added here. 1 plus 1 is 2. So I hope you have understood it. So you can write here 7 7. You have to write down the same number. 7 into 7. 7 into, actually it is 27. 7 7s are 49, 9, 4. 7 2s are 14 plus 4 is 18. So it is cross. So it is 17. So what is square root of 289? It is 17. Okay. Now in this case you have to find the value for cos A. So let us find out the value for cos A. What is cos A is equal to? Curly brown hair. Some people have curly brown hair turned permanently black. So cos A is equal to base upon hypotenuse, right? So which is equal to, what is base? What is B? What is B here? B is 8. Divided by, what is the hypotenuse here? It is 17. So we have got cos A is equal to 8 upon 17. Is that clear? Next, you have to get the value for cos A K. And you know that cos A is just the opposite of sin A, or the inverse of sin A. And you know that, what is the formula for sine of an angle? Sin A is equal to, some people have means P upon H. That is, sin A is equal to P upon H. That is perpendicular upon hypotenuse. But what is cos A K? It is just the inverse of sin A. That means if sin A is equal to P by H, what is cos A K? It is H by P, which is equal to, what is H here? H is 17. H is 17 divided by, what is P here now? Here P is 15. Here P is what? This is 15. That is, P is equal to 15. So we have got cos A K is equal to 17 upon 15. Is that clear? So now first part is done. Now let us prove 1 plus cot square A is equal to cosec square A. That is, LHS is equal to RHS. Now let us write down left hand side. So what is left hand side here? 1 plus cot square A. 1 plus cot square A, which is equal to 1 plus, what is the value for cot A? Cot A is 8 by 15. Cot A is 8 upon 15 whole square, which is equal to 1 plus, what is 8 square? 64. What is 15 whole square? It is 225. 15 whole square is 225. Okay. So what's the LCM? Here LCM is 225. So we have here 225, ones are 225 plus 64, which is equal to 289 divided by 225. So this is your LHS. Is that clear? So this is the value of 289 upon 225 is the value of left hand side. Okay. Now let us find out right hand side now. So RHS, what is RHS here? What is RHS here? It is cosec square A. RHS here is cosec square A, which is equal to, what is cosec A? We have just got the value for cosec A, which is equal to 17 upon 15. So this is 17 upon 15 whole square, which is equal to, now this square is for both numerator as well as denominator. We have just got the square root of 289, that is 17. That is 17 into 17 is 289. So 17 whole square is 289 divided by, what is 15 whole square? 15 into 15 is 225. So we have got this result. So what do we see out here? This LHS is equal to 289 by 225. RHS is also 289 by 225. That means we have proved that 1 plus cot square A is equal to cosec square A. That is, LHS is equal to RHS. So let us write here LHS is equal to RHS proved. Is it clear to all of you? So I think you have understood it. You can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 8. If sin C is equal to 2 upon 3, the value for sin C is given as 2 upon 3. Let us write by calculating the value of cos C into cosec C. So in order to get the value of cos C multiplied by cosec C, you have to get the individual values of cos C as well as cosec C from the given value of sin C. That is, sin C is equal to 2 by 3 is given. Okay, so let's do this problem now. So here given is sin C is equal to 2 upon 3. So from here, from the value of sin C, let us get the value for cos C and cosec C individually, right? But we know that, what is the formula for sin C? Now you should know it. Some people have some people have P by H, that is perpendicular by hypotenuse. If left hand sides are equal, right hand sides must be equal, that is P by H is equal to 2 upon 3, right? So from here you can equate the numerator, that is P is equal to 2 and H is equal to 3. So what is unknown quantity here? Base. B is unknown quantity here. So from Pythagoras theorem you can get the value for B. You know Pythagoras theorem. What is Pythagoras theorem? H square is equal to B square plus P square. Now what is H whole square? This is your 3 whole square. B square is unknown, plus what is P whole square? This is your 2 whole square, right? What is 3 whole square? 9 is equal to B square plus 2 whole square is 4. So I think you have understood it. So now let us get the value for B square. Let us take 4 to the left hand side. So this is 9 minus 4 is equal to B square. 9 minus 4 is equal to B square, or 9 minus 4 is 5, which is equal to B square, or you may write B square is equal to 5, or what is the value for B here? It is square root of 5. That means B is equal to root over 5. Now let us get the value for cos C first. Cos of an angle, that is C, cos C is equal to, what is the formula? Cos C in terms of perpendicular base hypotenuse. What is the formula for cos C? Curly brown hair. Curly means C, cos C brown hair, B upon hair, H. So cos C is equal to B upon H. What is B here? B is root 5 divided by, what is H out here? H is equal to 3. So this is root 5 upon 3. So let us get the value for cosec C. Cosec C is equal to, now you should know the formula of cosec C. As you know that cosec C is the opposite of sin C, or it is just the inverse of sin C. That is, you know, sin C is equal to, what is the formula for sin C in terms of perpendicular base hypotenuse? Some people have, some is sin, people have P by H, right? So what is the value for cosec C? What is the formula for cosec C? It is just the opposite of sin C or inverse of sin C. If sin C is equal to P by H, what is cosec C? It is H upon P, which is equal to, what is the value for H out here? H is equal to 3. H is equal to what? H is equal to 3. And what is P? What is P here? P is equal to 2. Here P is equal to 2. So we have got both the values of cos C as well as cosec C. But you should get the value of the expression cos C into cosec C. So write down given expression. So given expression is equal to cos C into cosec C. Cos C into cosec C. What is cos C out here? It is root 5 upon 3. Root 5 upon 3 into, what is cosec C? It is 3 upon 2. It is 3 upon 2. 3 gets cancels. So which is equal to, what is the answer now? It is root 5 divided by 2. So what is the value for cos C into cosec C? It is equal to root 5 divided by 2. So that is the answer. So I hope you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 9. So this question is very, very important. So you may get this question in short answer type of question, that is objective type of question, which question carries 2 marks. So write whether the statement is true or false type. Okay. So let us write with reason. You have to give the reason also. Whether the following statements are true or false. Whether the given statements are true or false, you have to write it. And you have to write down the reason also. Okay. So let's do this question number 1. The value of tan A is always greater than 1. So in the last online class, before we start this chapter, I told you about the formula. That is, the value of tan A may have any values from 0 to infinity. It may have any positive values. So in class 10, all these trigonometrical ratios are positive. So you should know that all the trigonometrical ratios are positive. So in these classes, we talk about only the positive values of all the trigonometrical ratios. That is, all sin theta, cos theta, tan theta, sec theta, cos theta and cot theta are positive. So all these angles lies in the first quadrant. Okay, so in this case, in class 10, we discuss about only the angles that lies in the first quadrant. That's why sin theta, cos theta, tan theta, sec theta, cos theta and cot theta all are positive in the first quadrant. So let us talk about only the positive values of all these trigonometrical ratios. Okay, the value of tan A is always greater than 1. Is it true or false? So I already told you that tan A may have any positive values from greater than 0. Tan A may have values greater than or equal to 0, and it goes up to plus infinity. It may have any positive values. So the value of tan A is always greater than 1 is not correct. It may be less than 1, but it is greater than 0. Okay, so here the statement is what? False. False. What is the reason behind it? Because 0 less than or equal to tan A, 0 less than or equal to tan A less than infinity. That means tan A may have any positive real values. Real values means defined values. Okay, tan A may have any positive real values. tan A may be greater than or equal to 0, but it should be less than infinity. That means it may have any positive real values. Okay. So the value for tan A is always greater than 1. No, it may be less than 1 also. So the statement is false. Is that clear? So next, let's do number 2. I hope you have understood this number 1. So number 2, the value of cot A is always less than 1. Here also I told you that cot A is always positive and it is always greater than or equal to 0. It may have any positive values like tan A. So the value of cot A is always less than 1. It is not always less than 1, but it may be greater than or equal to 1 also, because the value of cot A may have any positive real values. So this statement is also false, because the value for cot A may be greater than or equal to 1 also. Okay, false, because what is the reason behind it? 0 less than or equal to cot A less than infinity. Infinity means any values. Infinity plus infinity. This is actually plus infinity. Plus infinity means any real values. You may have 1000, you may have 1 crore, you may have 1 arab, etc. Okay, it may have any positive real values. So this is also false. Next, for an angle theta, it may be possible that sine theta is equal to 4 by 3. Can you say that the value for sine theta is equal to 4 by 3? So I already told you about the value of sine theta. The value of sine theta lies within 0 and 1 always, but the value of sine theta should not be greater than 1. So here 4 divided by 3. If the numerator is greater than the denominator, then this value 4 by 3 is always greater than 1. 4 by 3 means if you divide 4 by 3, you may have 1 point something, isn't it? So if you divide 4 by 3, that is 3 ones are 3, 1.0, this is 3 3s are 9, 1 again 0, 3 3s are 9, 1, and so on. 1.33 means it is always greater than 1. So you should remember that if the numerator is greater than the denominator, then the fraction is always greater than 1. You should know it. Okay, or if you divide 4 by 3, you will have 1.333, something like that. Okay, so you know that 1.333 is always greater than 1. So this value of sine theta is greater than 1 here. Is it true? Sine theta cannot be greater than 1. So it is false. So it is false because the value for sine theta lies within 0 and 1 always. So for this reason, this statement is false. So it may be possible that sine theta is equal to 4 by 3. Is it correct? No, this is false. Is that clear? Because the value for sine theta always lies within 0 and 1. So this is the reason, right? Next, number 4. For an angle alpha, it may be possible that sec alpha is equal to 12 by 5. So I already told you about the values of sec alpha. So sec alpha is just the opposite of cos alpha. And you know that cos alpha always lies within 0 and 1, but sec alpha does not lie between 0 and 1, but it should be greater than or equal to 1. Sec alpha should be greater than or equal to 1. Okay, so sec alpha is equal to 12 by 5. So numerator is greater than the denominator. If the numerator is greater than the denominator, it is always greater than 1, isn't it? Or you can divide it. Divide 12 by 5. 5 2s are 10. 2.0, 5 4s are 20, that is, it is 2.4. 2.4 means it is always greater than 1. 2.4 means it is always greater than 1. So the value for sec alpha is always greater than 1. Is always greater than or equal to 1. So here 12 by 5 is greater than 1. So it is true. So this is true. This is true. What is the reason behind it? Because sec alpha is always greater than or equal to 1. Is it clear now? Next. Now, for an angle beta, this is read as beta, this is a Greek letter. It may be possible that cosec beta is equal to 5 by 13. So I already told you that the value for cosec beta is always greater than or equal to 1. This cosec beta is just the inverse of sine theta, just the opposite of sine theta. Okay, or sine beta. If sine beta lies within 0 and 1, you know that If sine beta lies within 0 and 1, cosec beta does not lie between 0 and 1 because they are opposite function. So cosec beta should be greater than or equal to 1. But here 5 is in the numerator, 13 is in the denominator. And here numerator is less than the denominator. If the numerator is less than the denominator, this fraction is always less than 1. Okay, that is the value for cosec beta here is less than 1. So the value for cosec beta cannot be less than 1. So it is false. So it is false. What is the reason behind it? That is cosec beta is always greater than or equal to 1. Okay, so this is the false statement. Is that clear? Next, number 6. For an angle theta, it may be possible that cos theta is equal to 3 upon 5. So what can you say about this fraction? Is it greater than 1 or less than 1? This 3 by 5, is it greater than 1 or less than 1? So here numerator is 3 and denominator is 5. Here numerator is less than the denominator. If the numerator is less than the denominator, then this fraction is always less than 1. And you know that the value of cos theta lies within 0 and 1. So this is the correct statement. So it is true. So this is true. What is the reason behind it? Because 0 less than or equal to cos theta less than or equal to 1. So I think you have understood it. Okay. So now you should know this formula. Let us write it. Numerator divided by denominator is greater than 1 if what? Numerator is greater than what? Denominator. So if numerator is greater than denominator, then what can we say about the fraction? Numerator over denominator is greater than 1. Is that clear? Next, this n is numerator, right? This is the shortcut form. N is numerator, d is denominator, is less than 1. Numerator upon denominator is less than 1 if numerator is less than denominator. So you should know this formula, right? So if numerator is greater than denominator, then the fraction numerator upon denominator is greater than 1. But if numerator is less than the denominator, then numerator upon denominator will be less than 1. Is it clear to all of you? So I think you have understood it. So you can copy it. Okay. So I hope you have understood all these statements, which is true and which is false. Okay. So now this much is for today. So you revise all the problems that we did today. We have finished this chapter, and in the next online class we will do the new chapter, that is how to get the values of trigonometrical ratios of some standard angles. Okay, so this much is for today. So you revise all the problems that we did today at home. Okay, so you can copy it.